Hello everyone, welcome back. I am back with my series of Uniting Power Engineers series, webinar series number 22. First of all, I would like to say Happy New Year to all the participants. This is our very first program of year 2023 on the platform of Igniting Power Engineers with a very special topic, with a very special guest. The topic is SFRA or transformer, concept and interpretation with the Mahal agent of power sector, respected K K Murty Sir. First of all, I would like to tell you about the SFRA. The basic history of that SFRA is whenever something happens with your transformers, you perform many tests and you get piece of information from various tests. No single test can tell you the health of any transformer at all. You have to collect data from all the results piece of information, and based on the information you receive from all the tests you gather, you can make a picture as a complete picture about the health of any transformer. SFRA basically sweep frequency response analysis is a basically waveform for internal RLC complex circuits of transformer, which is used for future comparative purpose for investigation or diagnostic analysis. Basically, it tells us about the geometry and mechanical integrity of the transformers. FRA magnitude is the signal amplitude relationship between the reference input and the measure output. It is given in dB. That is nothing, it is the 20 log of ratio of output signal to the input signal. It contains the effect of characteristic impedance of the systems. It is very important to talk about why that SFRA is pertinent in the present era. It is required for verification that no damage occurred after the tap test of short circuit test. It is required when there is some relocation or commissioning validation. It is required to post-incident verification like lightning, external thorough fault, true fault, internal short circuit or seismic event. It is required to ensure some routine assessment and condition monitoring of all transformers. It is required for evaluation of use or spare transformer. It is mandatory after shipping and receiving at site. What I feel is the knowledge becomes meaningful when you start sharing it with others, with the societies. For the development of others, for the development of society, for the development of nation, development of globe. And this point is very well understood by respected Murty Sir. He is the right epitome of legend on earth. If you look at the names, alphabets, K K Murty Sir, that depicts many good qualities of a person he has. The first letter of K denotes the kindness he has. He's a kind, he's knowledgeable, he's a matured, he's a magical, he's unmatched and paralleled, he's ready to help, he's reasonable, he's rational, he's respectful, he's thoughtful and thorough, and last but not the least, he's young at heart. Before I give more introduction about this legend, I always talk about the persons who have helped me so far in my journey of this Igniting Power Engineers. I would like to thank from the core of my heart my family, my well-wishers, my supporters, my mentors, my friends. First of all, I would like to thank for Almighty, my family, my parents, my wife, my son. My mentors, respected PPY Saab, Anjali Chandra ma'am, K K Gupta ji, K K Murty Saab, who is already present, N K Mittal ji, P Ramachandran sir, S A Pao sir, Hitesh Chauhan ji, Dr. Kamal Bansal sir. My friends and well-wishers include Saket Gupta ji, Arvind Thukral ji, Dinesh Singh ji, S K Batra ji, Vishen Dutt ji. Last but not the least, my team working day and night 24/7 to making This show to happen, this show to run includes Gulab and Ramdhani. Now time to give introduction about today's presenter, Honorable respected K K Murty Sir. He holds a bachelor degree of electrical engineering. He obtained that degree from University of Jabalpur in 1968. He's a fellow of institutions of engineers. He's a chartered engineer. He's a member of SFRA India. He retired in March 2003, almost 20 years back. And he retired as a chief engineer and head of department testings and communication in MP Power Transmission Company, Jabalpur. He has worked as advisor at Southco, a discoms of Ambani Group in the state of Odisha. He was a metering consultant to MP Electricity Regulatory Commission. He was a course director to graduate ED training at a training institute of MP Power Transmission Company, Jabalpur. He was impaneled as the expert professional at the CPRI and interested with the third-party inspection job. He has published many technical articles in the national and international journals, and he has presented technical papers at various national and international conferences pertaining to power transformers and other equipments of power sector. Now, without much delay, I would like to invite respected Honorable Murty Sir, and I would like to hand over this stage to Murty Sir to start his presentation. And over to you, sir. Thank you. Thank you, everyone. Sir, you can unmute yourself and share your screen.
Where is this? What's happening?
In case you face any difficulty, we can share your presentation if you allow us.
Yeah, just a minute, let me see. Somehow, I don't know what has happened to this.
Sir, actually go to your desktop. Don't
Yeah,
share. And in desktop, you open your presentation, whatever you have already opened it.
yeah, I'll just open.
This one, sir, this one. You were on the very right track, Rahul. Fine, sir, fine. Kindly
Yeah,
make it.
wait. I'll just. You can see.
At the top, you can go the layout. Slideshow, yes.
Slideshow, yeah.
Yeah.
Slideshow, I have to come to this.
Otherwise, you can go to the bottom icon. You will get yes. Go right. At the bottom, yes. Make it full screen. Yes, it's okay right now. Please start.
Hello. You are able to listen to me?
Yes, sir. Please continue.
Whatever Dr. Arora has said, it is little exaggerated, I would say. He has introduced me as a legend and all that. So, whereas I had been an average testing and commissioning engineer, having hands-on experience as an AE up to 1980, I was confined to MP state transmission utility only. You are able to listen to me, sir? Hello.
Please, yes, sir. Please continue.
I am sorry for the delay. Of course, yes. Good evening, the participants, rather distinguished participants who have joined this webinar. Dr. Arora has introduced me as a legend, whereas I had been an average testing and commissioning engineer, having hands-on experience as an AE up to 1980. I was confined to MP state transmission utility only. Opportunities make anybody grow in his or her field or profession. In my case, I too got opportunities to grow. I was given a platform by CBIP by Engineer P.P. Saab and the platform of CPRI by Engineer B.V. Raghoya Saab, Spark WhatsApp group by Engineer P.K. Patnaik Saab, and last but not the least, Dr. Arora, who gave me platform of SIP earlier, and now his webinar. I shall be ever grateful to them. These platforms and Spark WhatsApp group gave me opportunities to meet the stalwarts of the power system, who became my gurus and guides. They are Engineer P. Ramchandran Saab, Dr. Rajamani Saab, Engineer M.L. Jain Saab, Engineer Virendra Lakhiani Saab, Engineer Sanjay Patki Saab, Engineer P.K. Patnaik Saab, and the youngest of all, Dr. Arora. I bow my head before them. You must be wondering, being an old timer, how I could get this thought of writing this paper. You must be wondering, while witnessing the factory acceptance test of 315 MVA 400 kV transformer at the works of Siemens India at Kalwa, on behalf of CPRI Bangalore in the year 2010, I saw SFRA test being carried out for the first time in my life. Engineer Rakesh Patil of Siemens explained me the importance of methodology of SFRA test. I owe him for this. Then it came to my mind, why not write a paper on this? Now coming to the subject, it is on the concept and interpretation of SFRA. Concept calls for tutorial. Tutorial has to be such that each and everything has to be explained in a simple manner such that a subject is understandable. Anybody who knows SFRA is not very difficult as you learn from the abbreviation, but yes, anybody who knows little about transformer and RLC's this circuit can understand SFRA concept. With this, I would like to start my presentation. See, as I've already said, that transformer is inherently as unique RLC circuit of each one of them. Since this RLC circuit consists of resistance, inductance, inductive reactance, and inductive capacitance, it is RLC circuit only. And as far as everybody knows, resistance is it's non-frequency dependent, whereas inductive reactance and capacitive reactance are frequency dependent. Thus, every transformer has different impedance, which varies with the AC circuit with the variable frequency. As you vary the frequency, the variable, the signature, rather the graph will also vary. In this case, as you see, XL is directly proportional to XL is this is omega L. XL is omega L. Omega is 2 pi f. Likewise, XC is 1 upon omega L C. That is omega C. That is omega is 2 pi f C. So as frequency increases, the inductive reactance increases, whereas capacitive reactance decreases. This is the basic concept of this. And as far as the SFRA is the acronym of frequency response analysis. It is nothing but dependent on frequency. The magnitude is measured in dB or the frequency range of 20 hertz to 2 megahertz. It is designated as non-invasive test as dismantling is not required. Maiden curve taken at the works is called signature curve or thumb impression. The first standard was prepared and published by the People of Republic of China in the year 2004. Now, concept, theory and concept. I don't know why you stop sharing. See your screen share. Signature curve or thumb impression curve is taken at OEM's works before dispatch. As you see, is this admit? As you see, this is core of the transformer. This is the winding. Winding is nothing but it has got the shape of a circular this thing. So that's why it has got this inductance and the capacitance, the winding to winding capacitance, the winding to core capacitance between the LV winding to core, HV winding to LV winding, and HV winding to the body of the transformer. And so that is how it is the transformer which it when it leaves the OEM. OEM means original equipment manufacturer. OEM's works. The SFRA is taken, which is known. The signature thereof is known as SFRA signature, signature curve or thumb impression curve. Is taken at the OEM's work. Now, this figure is of distortion during transportation. The transformer nowadays is transported on a multi-wheeled, low-bedded trailer, tractor trailer. It is known as tractor trailer. So, if it gets a jerk or shock during the transportation, the capacitance and the inductance will change with respect to each other as well as with respect to the core. So suffered core distortion during this particular figure shows the distortion during the core distortion during transportation. Thus, XL and XC shall vary, resulting in distortion in the curve with respect to signature curve. Now, this is the test. I don't know why this. Excuse me. There's a black this thing. It is hindering the. It is coming into my presentation. I don't know. Is Mr. Is Mr. Gulab there?
Sir, from our side, there is no issue. We are getting the full screen. I think there is some issues at your laptop. From
I
our
don't
side, we are getting a full screen.
I don't know. I don't know what is this thing. Anyway, so test setup. Test setup is this figure shows the test setup. Here, this is this particular this thing is the schematic of the test SFRA test kit, and this yellow one, you have to magnitude of this V input, and V output. These two quantities have to be measured, and the magnitude in dB has got the relationship 20 log V output upon V input. This is the magnitude. So for this, the connections are like this. This is the V input connection, okay, and this is the V output connection. Whereas the coils have to be whereas the coils have to be cable have to be coaxial cables. So, and this the green lead which is seen here. This is actually the shortest distance you have to use this, and they are the braided copper cables which are connected onto the top of the transformer, and which further goes to the earth as well as to the earthing point of the equipment. The frequency range is 20 Hertz to 2 megahertz at output of 10 volts from the kit. Now, SFRA test, when to perform. This is very important when you are supposed to perform the SFRA test. After the short circuit test, as you know, short circuit test is the test which is taken in the OEM's works against the type test, which is prescribed in the IEC 60076-5 or IS 20265 at OEM's works. After receipt, number one is this, after short circuit test. Number two, after receipt test site. After receipt test site, as I've already told you, I've shown you the slide, this slide, wherein there is likely to be any dislocation during, just to verify whether there is any likely dislocation of the dislocation of the core. So it has to be taken after received site. Relocation of one site to another site in same switch yard as well as well. This is another this thing. When you are relocating from one site to another site, there is every possibility of jerks or thrust what the transformer may experience. Post incidences: lightning, external through fault, internal short circuits, bushing failure, severe seismic conditions, etc. After the transformer trips on or alarm on, differential or REF protection, PRV trip, Buchholz alarm trip, DGA report indicating thermal faults above 300 degrees centigrade, indicating T2, T3 conditions as depicted in IEC 60599. This is T3 is which is more than 700 degrees. T3 is more than 7 degrees, and T2 is more than 300 degrees. This is a degree sign. Actually, it looks like a 0. So you please read it as degree. Now, region-wise frequency response. So the frequency response has been divided into 4 regions. This is A region. A region consists of a core which is less than 2 kilohertz. This is a log-log scale. which is divided into this is the 1 kilohertz, and this is 2 kilohertz line. This is A region. B region is 2 kilohertz to 20 kilohertz. This is 10 kilohertz. This is 20 kilohertz. Likewise, this is the third is 20 kilohertz to 1 megahertz. This is 1 megahertz. 1 megahertz means 10 raised to 6 hertz. So and it is very high. This generally this is the measurement setup and lead inducting, including earthing connection, etc. So mainly this A region, B region, and C region are important. So A region consists of core. So as you see, the curve comes like this and like that. So here you can see there's a yellow, blue curve and red curve. Okay, so red curve has got this notch. So that is because of the reluctance path of the outer limbs of say A phase and C phase, whereas this is of B phase. It will not have any notch because the reluctance path is similar in both the on either direction. So this is basically of core, indicating the condition of the core. This is B zone indicates the condition of the windings and interaction between winding, and C zone is the it is because of the it will show the condition of the individual winding structure. This is a better this is the exclusively drawn figure for better understanding and clarity. So it is the same figure what we have seen in the last last slide. Only thing is its clarity is there. So because of this, I enlarged it. Now, as you more. Anyway. This is a very FAQ. FAQ is nothing but frequently asked questions. Now, this came to my mind only when a question was raised by one of my associates, engineer Shiv Kumar Chaturvedi, assistant engineer 400 kV substation company. He asked me, sir, I have been asking many commissioning engineers, but they have not been able to answer my question. Every transformer has got this drooping curve. You can see this drooping curve. So every transformer is seen. It has been observed that every transformer has got this drooping curve. So can you, sir, enlighten us? So I said, then it was a challenge to me. Then I thought I must think about this and try to do something and wreck my head to answer his question. So it is basically, if you see this chart, this is the point of resonance, where the frequencies XL and XC, they are equal. So where I have already told you that XL is omega L is equal to 2 pi F, 2 pi FL. F is the frequency. So as frequency increases, XL increases, whereas as frequency and here 1 upon omega C, XC is 1 upon omega C is equal to 1 upon 2 pi FC. So 2 pi FC, where when FC increases, that frequency increases, XC decreases. So reasons, so you can see when the frequency increases, see when the frequency is increasing, XC is decreasing and XL is increasing. So this is the point of, so from minus 38, so it comes to minus 97. And so this is the point of resonance. The reason is due to the series resonance between the magnetic inductance of the core and the total capacitance of the transformer. Perhaps I don't know if anybody will have any doubt about this, but yes, this was my answer to him, and that engineer S.K. Chaturvedi was quite satisfied. So that is why I have written this as a FAQ, frequency asked questions. Now, wait. So, reference condition for status evaluation. So you have to have reference condition for the status evaluation of any SFRA, any condition of the transformer when you're carrying out SFRA. So this is the time-based condition. I'll just please excuse me. I'll just ask somebody to clear my this thing. So please hold on for some time. So this is time-based the reference conditions. So time-based condition. Hello. Time-based condition. This the transformer suffers many stress and strain during operation, such as mal-operation by the operating staff, overloads, overfluxing, tripping due to external faults, and also during seismic disturbance condition. Hello. So you can see the curve here. The red curve is of say dated 8/8/2006, whereas the blue curve is 14/5/2007. So this was the original curve, and the blue curve is the later curve. So this difference will be there. So it is not to be understood that the transformer has some problem, but this has got this can be accepted. Then comes the comparison with sister transformer. See, T1 is one transformer and T2 is the sister transformer, but they may not be similar because of the due to the minor variation in capacitances between the core and the LV winding. There may be sister transformers must have been manufactured in the, under the same design and all. But while manufacturing, there could be some variations due to minor variations due to capacitance between the core and LV winding and HV winding to LV winding as well. So in that case, when though no sister transformer is available, the only way is to verify the transformer's healthiness through the through its own phases. As you know, the this A and C phase, by being in the outer limbs, will have the same similar characteristics since the this reluctance path is same for both that for the outer limbs. So they will overlap each other. As you see here, you can see this blue color and this green color. They are of A phase and C phase. So you can see A and C phase are overlapping each other. Whereas B is the this red is the B phase. B phase is the middle phase. Middle phase is like this. So if there is any problem, if some deviation is found in SFRA trace, it will confirm that transformer has developed some defect. So what I have said, you can see this, since magnetizing current of the middle limb is less than the outer limbs due to less reluctance path than the outer limbs. Therefore, the magnetic magnitude thereof is less than the other limbs. So this, of course, you can find those who have worked in the field, they will see that while conducting the magnetizing current test, you will find that the the current taken by the middle, magnetizing current taken by the middle limb is less than the outer limbs. Then comes the deviation in SFRA curve. Then comes the when the transformers come, the basic mostly the bigger transformers, large transformers are transported with nitrogen filled, okay, and oil is not filled. So whenever they either nitrogen filled or dry air filled. So in the OEMs works, they generally take SFRA curve with oil-filled transformers, and they remove the oil and then they transport the transformer with the nitrogen filled or dry air filled. So in that case, the SFRA curve will have difference, as you see from this is the red colored curve is full oil when the oil is full, and blue colored is without oil. So you can see this because of the dielectric strength of oil and say nitrogen or air is different. So that is why in all the frequency ranges there is a difference. So what is observation? Deviation is SFRA curve in all the frequency ranges. Advice. This is the basic advice. Never compare SFRA of a consignment of oil-filled transformer with dry air or nitrogen N2 filled transformer. So this has to be taken care. Otherwise, you will feel that there is a lot of problem with the transformer and all. No, it is not like that. So next is comparison between mineral oil and ester fluid. It's also like that. As you see in the previous slide, it was because of the dielectric strength of say oil and the N2 or air. Similarly here, natural ester and mineral, the comparison is between mineral oil and the ester fluid. Ester fluid means it can be natural ester or synthetic ester. So what here in this particular this thing is natural ester is shown here. The curve is of natural ester, red curve is natural ester, and blue curve is of mineral oil. You will see that in every full range of frequencies, right from say 20 hertz to 2 megahertz, it is different from each other. It is because of basically the dielectric strength of different mineral oil and that synthetic oil, ester oil. So because of that, you can find this what you call difference in every frequency range. So what is the advice? Never compare SFRA curve of sister transform filled with mineral oil with that of filled with ester oil. So transformers may be of the same design, but one should not compare a sister transformer with different oil, say mineral oil and the ester filled oil. So this is the advice. And now next is As everybody, as the transformer commissioning engineers and the people who deal with transformers know that the uh, winding resistance test is nothing but DC test. So when you are taking winding resistance test, the core gets magnetized. So the deviation will be definitely there before DC test and after DC test. When you take the SFRA, before magnetic test, magnetizing, before winding resistance test and the after winding resistance test, there will be difference. Definite difference will be seen in the this core area. That is this core area is 2 megahertz. 2 kilohertz area. This is the core area. So here you can see the difference. In other frequencies, the difference is not. Here you can see distinctly see the difference. So red color is before DC. This red color is before DC. Before the transformer, the core is not magnetized, and blue is after DC test. Here you can see the curve is the magnetized because the core is magnetized, the division is there, and in the lower frequency also it is coming here, unlike this red one. So deviation in frequency response curve takes place in the core area A. This is the core area A. This is core area A. That is 2 hertz, 20 hertz to 2 kilohertz is the core area. Now, tertiary delta is open frequency range. Open. See, tertiary delta, many these what you call utilities want that tertiary delta should be open, and they have the tertiary delta is there in most of the auto transformers, and so many utilities they want that the tertiary delta should not be closed, and they should bring two bushings at the top of the transformer, which can be closed while earthing it. They can be closed while earthing it, and for testing purpose they can have the open delta, and the curve of open delta has to be like this. Open delta is blue, red. Open delta curve is this red. Okay, so this is because of the tertiary delta is open. If the tertiary delta is open, frequency range of the series winding is affected, especially in the intermediate frequency. That is 2 hertz. This is 2 hertz, 2 hertz to 20 kilohertz. This is 20 kilohertz. Okay, this is 10 kilohertz, and this is 20 kilohertz area. This is 2 hertz and 20 kilohertz. You can see this this red curve of open delta. Okay, when the delta is opened and tested. So reason is due to inductive and capacitance coupling from the tertiary delta, which causes anti-resonance and resonance in this frequency range. With what? With the series winding. And what is series winding? So one must understand what is series winding. So for clarity, I have given this slide. This is the basic schematic diagram of an auto transformer. This is a basic schematic diagram of an auto transformer in UVW convention. UVW convention. Basically, when you see the transformer, you will not find RY on the bushings. You will find UVW. U stands for R phase, V stands for Y phase, and W stands for B phase in RYB convention. So here you can see this. There are 2 windings, and from here the tap is this is the IV winding, means the lower voltage. One U is HV winding, 2U is IV winding. IV is the intermediate voltage, and 3U is the LT winding. This is known as LT winding, which is of tertiary winding in auto transformer. So here you can see this 1U and 2U, they form the series winding. This is the series winding. Okay. Whereas this is common winding. This is common for 1U, and this is also common for this 2U. So you can see this affects the series winding, is affected, especially in the intermediate frequency, that is 2 Hertz to 2 kilohertz, 2 kilohertz to 20 kilohertz. And this is, of course, when the delta is closed and ungrounded, and when the delta is closed and ungrounded, and when the delta is closed and grounded. Most common practice of many utilities is, if delta is not used, it is grounded. It is a general practice to obtain SFRA curve with the closed ungrounded delta in the works of OEM. OEM, when you go to OEM for FAT, that is factory acceptance test, you will find that they will take this SFRA curve with closed delta ungrounded. So this is the closed delta ungrounded curve. So in practice also, when you are testing the transformer with closed delta, so you have to remove the this earthing lead from the delta bushing, that is U3 bushing. It is recommended that SFRA transformer should be obtained after disconnecting grounding lead from delta tertiary winding. If inadvertently the SFRA curve is obtained without removing the grounding connection, then the curve in the region C will be shown in red color. So if delta closed and grounded, you will find this. This curve is, you can find this difference. So with the ungrounded, this blue one is the ungrounded curve. So this you can see. So different circuits for plotting sweep frequency response curves. So there are 4 different practices. This is known as the open circuit this scheme, in which this is the delta, which is open circuit. Say A, B, and C. In this, the ABC convention is used. So you can see this this capital A, capital B, capital C is the HV side, which is star, and this is the delta, where A, B, and C is there, which is open, which are open. So the curve will come like this. You will find this curve like this. And the next one is closed. This is the shorted. Okay, the LV is shorted. So in this, this is known as shorted LV. So in this, you can find that, say, whereas this connection is same as the previous one, you can see this connection is same. Only this portion is shorted in the subsequent this thing. You can see this. Open circuit measurement and short circuit measurement are the vital measurements for diagnosing the health status of the transformer. This is the basic takeaway for anybody. You don't have to go for 2 more connections are there, which I will go ahead and show you in the further 2 stage this thing. This is capacitive. This thing, capacitive measurement between HV and LV. Okay, so In this, you can see the say AN is being taken in this case. In this case, there's a this A is earth, whereas here also the A is also earth, and no other earthing is there. So, but this particular thing is not valid for auto transform, because auto transform is not magnetically separated. It is the common winding is there. So capacitive interwinding measurement is not is measurement between two electrically isolated windings. So in a conventional transformer, you can have this, but not in auto transform. That has to be taken care. That has to be kept in mind. Okay. Otherwise, many people, it has been my experience. The younger lot, when they do this thing IR value. So when they do the IR value, they'll take IR value of all the three phases. So whereas it is not required. IR value of one phase is good enough, because all the phases are interconnected. So that people, the younger lot may not have that idea, but yes, that is where one must, the senior people must make them understand. So this is inductive measurement. Inductive measurement, in this you can find that see, this is this is capital AN. It is at N, and the corresponding LV line, LV winding is this is you can see this LV winding is V output is A is earth and B is earth. AB is the winding, okay, which has to be which has to be measured with the HV winding A and F against HV winding A and F. So this is the curve for that. This is all. This is not required. These two, this inductive measurement and the capacitive measurement, are not very. They are not required, because that short circuit measurement and the open circuit measurements are good enough to identify the status of the transformer. Now, this is the summary of the SFRA, which is the analogy with the conventional tests. It has got the analogy. So many people, so it is just a summary, you can see. So this is open circuit test. This is something like similar to excitation test. And similarly, short circuit test, similar to the leakage reactance test. It is similar to the conventional leakage reactance test. And this is capacitive interwinding test. It is a capacitance test, similar to capacitance. And this inductive interwinding test, it is similar to TTR. TTR, transformer turn ratio, similar to transformer turn ratio. This I will show you in the upcoming slides, how this has been used for finding out the turn ratio. And this is the just a minute. This is the sorry.
So it is repeatability and its importance.
Yeah, it is repeatability and its importance. So for repeatability and its importance, this is why it is important, because when you want to make the this thing the conditions of the SFRA while it was taken in the works. So for that, you can have you will have to have the leads. Leads must be the contact of bushing. These are the contacts of bushing. Have to be correct and all the connections from the tank have to be removed. All the connections from the tank have to be removed, but for this connection, all other connections, say the uh, uh, in case of say neutral and of course neutral when you're testing for different this thing that has to be there. So the connection from the transformer except tank grounding should be removed. The contact of the bushing should be cleaned and the connection clamp be tightened firmly to ensure reliable and electrical connection. Shielded high frequency cables, usually coaxial cables of exact same length, should be used. The test cable shield must be connected to the base of the bushing through broad braided copper strip. This one, broad braided copper strip. These are broad braided copper strip, and they have to be as short as possible. The test cable shield must be connected to the base of the bushing through broad braided copper strip, green colored, and shall be as short as possible. It is very important to ensure reliable contact between the copper braided ground lead, green color, to the tank and then to the ground. This one, uh, this one, and this one. It is very important. It is very important to ensure reliable contact between copper braided grounded lead, green colored, to the tank and then to the tank, means this one, and then to the ground as well as to the point in the as well as in the, excuse me. हाँ बेटा आना जरा जल्दी से. अरे ऊपर कुछ आ रहा है यार, वो गड़बड़ हो रहा है. Where are you? अरे यार, then don't worry. Then it's very important to ensure level connect. So next is the detailed information about the test set should be stored together with the test data. This is very important, and detailed photographs are also recommended if available. So this is the now next is this curve shows wrong connection, bad connection. See, HV to neutral, good connection. This red one is the HV to neutral, good connection, whereas the green one is HV to neutral with bad connection at neutral, and the blue one bad connection to this blue one. Blue one HV to neutral with bad connection at neutral. This blue one, and this green one is HV to neutral with bad connection at HV. So these three conditions, these two conditions are very important, which one must take care while connecting the kit. One of the sample this case studies I have shown this also, wherein the kit was not properly arched. Of course, this is the connections of the leads of the test leads for measuring V1 and V2, whereas that is about the connected case studies. Now comes the case studies. This has got three case studies. One is this, you can see the this noise here. This is due to the effect of induction of live 400 kV overhead conductor gantry to gantry stringing. See, if the transformer, another transformer is being commissioned just underneath the gantry to gantry stringing of single phase transformers. This was of course at Indore. So after this, after taking shutdown on 400 kV single phase transformer and discharging the bay, then you can see this, the curve has been smoothened. So this was the first case study, wherein the induction effect, how the induction of the substation affects the SFRA. close in the vicinity of the affected induction area. So this is the next one. SFRA kit was not firmly connected to earth. Okay. So the curve was like this. You can see the distortion. SFRA curve after firmly connecting the SFRA kit to earth. So you can see it is a smooth curve here. So this is the number 2 case study. And number 3 case study is number 3 case study is
It is a post-fault SFRA
post-fault SFRA analysis. Brief description of the incident. Inadvertently closing 400 kV breaker post maintenance of 315 MVA auto transformer. This is 400 by 220 kV, 315 MVA transformer. While 220 kV earth plate was on. So what was the observation? Heavy flashover observed on 220 kV earth plate. Tripping indications and alarm. These had appeared. Differential trip A phase, high set differential. PRV operated, Buchholz alarm and trip appeared. High set R phase earth fault operated. Now, this curve, this SFRA curve, okay. So this was taken post incidence, of course, and the HV to neutral, keeping all other terminals floating. Who is this? So you can see this the curve here. So the curve shows that as the indication shows that differential A phase. Okay, A phase in ABC convention, of course. Differential A phase, high set differential, PRV operated, Buchholz alarm and trip appeared, and high set R phase earth fault operated. Here A phase, it is because of the convention used in differential relay, it is A phase, and most of the operators say R phase earth fault, or the relays. In general convention, we have R phase, Y phase, D phase. That's what we say. So one should not get confused because of this nomenclature of the phases. So here, this is a area which is the core area. Okay, so you can see this in this core area. Conventionally the curve should come like this. Okay, this is the curve of other two phases, whereas this is the curve of R phase. Okay, you can see the this distortion here, and contrary to this, the curve comes from the droops down. It is going up. You can see this is the R phase blue colored amplitude rises from -44 dB to 15 dB. That is frequency response curve is rising in amplitude, contrary to the characteristic of response curve, drooping from higher amplitude to lower amplitude. It should droop from higher amplitude, whereas it's going up. So this is one defect. What would the irregular distortion in the amplitude of R phase in A region between 30 and 60 hertz. This is 30 and this is the R phase. That's what I have written here. You can see this. Okay. And R phase response curve is irregular and distorted in the frequency range zone B, and also extending up to 60 kilohertz in this zone C, indicates that winding is badly affected, involving common winding. So here you can see this blue here. So this point is 60 hertz. See, this is 100 hertz, 100 kilohertz. So this is 60 kilohertz up to here. So this is this ellipse what I have drawn in B this thing area region. So winding configuration of auto transfer is shown in the next slide, which I have already shown you earlier. The same thing I have repeated. So here you can see this series winding is this 1U and 2U, whereas the common winding is this 1U and N and 2U and N. This is common winding. Now, this is the next thing. Keeping this IV. IV is the test was taken from IV, keeping all the other terminals floating. Whereas you can see this is as per 60076/18. You can find this. So this is the actual curve. And with the fault, the curve has come. Okay, like this. The shape has taken. This is the after fault. The curve is after fault. Simple sample frequency response curve of tap winding of an auto transformer before and after fault, showing axial collapse and interturn short circuit is depicted in the picture alongside. This is the picture. So the curve what we are got that resembles this. You can see this resemblance. See, it is coming like this. So it is resembling the same way. Yes, you can see this. Okay. So drooping of the curve in parabolic shape from 1 dB to 27 dB. This is 27 dB. Okay. So 27 dB in A region resembles the sample curve. Thus, it is opened means opinion. This is my opinion. That turn-to-turn short in the tap winding must have taken place in R phase between the IV terminal to neutral. So IV terminal to neutral. This is IV terminal. IV terminal to neutral here. Here it must have taken place in this tap winding. IV terminal. It comes like this. Okay. So this tap winding comes into picture. So R phase curve, so thus it is opened that turn-to-turn short in the tap winding must have taken place in R phase between IV terminal to neutral. R phase curve in section B. This is the section B. Okay. R phase curve in section B is erratically distorted in the frequency range 9 kilohertz to 60 kilohertz. See, this is 9 kilohertz. It is 9 kilohertz. Okay, 9 kilohertz to 60 kilohertz. 60 kilohertz here. And the 100 kilohertz is here. 60 kilohertz here. Okay. As shown encircled in M. This is M encircled, ellipse. Indicates that R phase common winding is badly affected. So you can see the findings. So when the transformer is opened and seen, so you can see this. This is the lead of R phase winding that IV. R phase IV lead. This is, you can see the black end here. The R phase winding lead and vicinity thereof observed to be heavily carbonized, and vicinity thereof is heavily carbonized, and also burning of paper insulation, heavily carbonized, and also burning of paper insulation, and core also got affected as shown in left hand figure. This is the core. Core is also affected. Whereas why we say that core is also affected? Because you can see, because you can see this is the core area. Okay. And here you can see the core is affected. So this confirms that the curve what we have seen is authenticating the actual fault. And about this, coupling between selector switch and diverter switch of R-phase OLTC found separated. This is the MR type trap changer. MR type trap changer has got two portions. One is the selector switch and the other is diverter switch. So selector switch is inside the transformer, whereas the diverter switch comes up. The diverter switch on the top of the transformer. It is in a this cylindrical form which goes in the transformer, but the oil of diverter switch is not not mixed with the oil. It cannot be mixed with the oil of the transformer, whereas the selector switch is within the oil of the transformer. So coupling between the selector switch and diverter switch of R phase OLTC found separated due to breaking of fastening brackets of the selector switch assembly, perhaps due to axial force as shown in right hand figure. You can say this is from here broken bracket. You can see here. Okay, broken bracket here and broken bracket here. This is where this must have taken place because of the axial force on the transformer, on the this thing diverter switch. Now this is my presentation as such is almost complete. This is an innovative idea of SFRA ratio test on transformers by Long Pong, Senior Principal Engineer, Client Service, Doble Engineering Company, US. So this I have taken just for academic interest. You can see this is the kit, and you can see that this is the connection made is the inductive interwinding connection. Okay, this is LV winding and this is HV winding. So this is similar to what we have shown. We have seen test connection is same as inductive interwinding measurement Y and D1. For this Y and D1, this is Y, and this is D1. This vector group is Y and D1. So you can see it is similar. See, this A phase is resembling this, and this LV A phase is resembling this. So in this connect as shown in this slide 31, okay, sorry, this is 37 actually. The slide I have to correct it. I'm sorry for this. So 20 log V upon this is the with this the next is this log 20 log V upon V1 is equal to dV. The SFRA ratio is V1 upon V2. So this ratio we have to find out. The SFRA ratio found from the graph must match with the nominal ratio. The ratio of 40 MVA 120.75 divided by 13.2 kV. Y and D1 is the ratio. Nominal ratio means this is the Y and delta 1. YN means star, and this is D. So the winding of star is phase to neutral, which is which has to take care, which is inductively connected with the delta winding. Of course, the rather magnetically connected with the delta winding. So the ratio is 5.281. So this is 120 divided by root 3. Sorry, yeah, 120 divided by root 3 divided by 13.2 kV. That comes to 5.281. This ratio must be very near to the nominal ratio. This ratio has to be very near nominal. If the turn is shorter in the LV winding, the curve will move towards higher ratio. Why it will go towards higher ratio? If you remember, in any transformer, the turn ratio is such that LV winding has got lesser turns and the HV winding has got more turns. So when this LV winding curve will move towards higher ratio, means the LV winding uh, is shorted. When the LV winding is shorted, means LV winding is in the denominator. If it is shorted, means number of turns are less. So naturally, the resultant will be more. Okay. In the other case, when the lower ratio is given, so indication that HV winding has shorter turns. So HV winding has shorter turns means HV winding is in the numerator, and LV winding is in the denominator. So if the numerator turns are less, so naturally the number of turns are, since number of turns are shorted, so numerator turns are less. So the curve goes towards the lower side. So this is what is shown in the subsequent curves. This is the result of a healthy transformer. See, this is 5.28 is the ratio R to R, and R to I is 5.280, and B to B is 2.85. So this curve is like this. There is no this thing. They are almost same. So normal turn ratio 5.28 bar. The SFRA is reasonably close to nominal ratio. Analysis no fault detected. Okay. No fault detected. So next, you can see this analysis turn to turn fault in LV winding. So turn to turn fault in LV winding. Here you can see turn to turn fault in LV winding. So when the LV winding has got fault, so naturally the ratio will be more, because HV winding is constant and LV winding is the turn ratio of LV winding is the denominator. So naturally if LV winding has gone short, so naturally the ratio will increase. So in this case, R to R will be 16.381 and Y to I is 17.016 and B to B is 16.385. So here you will see that this Y the curve has gone up. See this curve has gone up. So here the nominal ratio is 16.4 and SFRA ratio deviates from nominal ratio. So Y to Y trace is higher than the traces of other two phases, indicating that fault is present in LV winding. That is why analysis LV winding turn fault. This is the analysis. And turn to turn fault in HV winding, the curve will be like this. See, when HV winding turn to turn fault is there, so the ratio will be less, okay, than the nominal ratio. Nominal ratio turn is 7.072, and in this case, 7.072. The R to R trace is lower than the traces of other two phases, indicating that fault is present in HVR phase. Analysis turn to turn fault of R phase HV winding. So this comes to more or less completion of the presentation. SFRA is a powerful, this is the conclusion. SFRA is the powerful non-invasive technique for assessing health status of the transformer. It is a single test to evaluate the mechanical and geometrical integrity of the transformer. This test is adopted in a big way over all over the world, subsequent to issuance of international standard and SIGRE reports, that is the IEEE, this is international standard is IEEE C 57147 -212 2012 and IEC 6007618 2012. These are the international standards. And reports of SIGRE working group is A2 group is for transformer in SIGRE. SIGRE is the largest world's largest institution of all the countries for large power equipments. SIGRE is in Paris. So working group is A2. The report is 342. A2 342 in April 2008. And the next group, working group is the report is 812 September 2022. I am proud to say that this 812 group 2022, this consisted of a representative from India. He is the engineer R.K. Tyagi from Power Grid. He had gone as a representative from India in this particular group, A2 group. The report is 812 September 2022. And it is the last slide, last but one, of course, the gratitude and acknowledgement. I express my gratitude to Dr. Arora, Dr. Rakesh Arora, and his organizing team for webinar, team of webinar, who have given me an opportunity to present this paper in this webinar of IPE. I express my thanks to the technocrats who attended this webinar and patiently listened to my deliberation. I dedicate this webinar to my beloved wife, late K Murty, who had been a great inspirer to me. And this is the end of presentation. So thank you so much for patiently listening to my deliberation.
Sir, thank you very much. I don't have exact word how to say thanks, because I have become emotional, because at the age of 80 and after retirement of 20 years, you are contributing to the society in a big way.
Dr. Arora, I have been always saying that age is no bar for learning.
Yeah, that's why.
So
that's in the beginning.
This is the, in fact, I retired in 2003, whereas this particular SFRA came into being in 2004. 2003, I retired and it came into being in 2004.
Mind blowing.
So that is
kindly stop sharing, and now time to ask question answer. And
so what should I do now?
Stop sharing.
Stop sharing. Okay.
Yes.
Okay.
Now, again, I would like to say thank you for this kind, knowledgeable, matured, magical, unmatched, unparalleled, ready to help, thoughtful, thorough, and young at heart engineer K K Murty Sir. Now, I would like to invite the mentors of everyone, PP Sir. He is here to give his blessings. Kindly unmute, sir. Before I start question answer. Vice up. Gulab, kindly unmute, kindly allow.
No, I definitely would like to like to have blessings of Vice up. He is the person who had given me the platform CBIP for going to go for. I had grown in CBIP platform because of that.
Allow him to speak.
Yeah.
सर PPY सर साउंड मतलब वॉइस से कनेक्टेड नहीं है.
I can see him.
Sir, Vice up, kindly unmute yourself. Okay, in the meantime, I would like to invite my other mentors of everyone, Mahal agents, S. Apau Sab. Kindly unmute and say a few words.
Good evening, Rajesh ji. And it's a wonderful, wow, how I should appreciate Mr. K K Murty Sir, as he told at this age. It's an inspiration. It's an inspiration to our senior people that we can gain knowledge as the age also goes high. So the thing is, he's making minute interpretation. Really, I wonder. I get hats off to you, sir. The interpretation as if you are a young, energetic 20 engineer in the age of 20s and 30s. You are giving. That's very good. Especially, I am not an expert. Frankly speaking, I am not an expert in this subject. But however, I have learned a lot today. Whenever I appear for a seminar, I would like to grasp something, whether it can be helpful to my field of earthing and other safety measures. Today also I am having idea Actually, this is almost an ECG. ECG for the man. This is ECG for the transformer.
Yeah. Very true. Very true.
Yeah.
You have rightly analyzed, given the simile, sir.
No, only the third man can give you unbiased thing, because I am not an expert. That's why I'm saying. Another thing, you have explained a lot of intricate analysis, especially signal analysis, as well as the interpretation. That depends. Instruments are showing a lot of curves, everything, which are alien to us, but the experts can interpret it in the right way. So expert, despite the showing of instruments, everything, experts is always required to make it a correct sense out of it. That's the thing. And one more doubt I'm having is, it can be used, of course, it's a offline test before analyzing a transformer, what happens during the idle period. So it can be used for a preventive rather than the condition monitoring. It is what I presume. I may be wrong, but I presume that it can be used as a preventive thing during shutdown.
Definitely, sir. But one has to include this in their schedule for maintenance of the transformer. Whenever they take a shutdown, say after at least after 2 years or so, they should have a SFRA also. That is, I feel.
Yes.
It is also used.
Actually, it's a harmless. It's a harmless and non-intrusive. More or less, non-intrusive.
Sir, it is also used for condition monitoring for some spare transformer lying at your side for many years.
Yeah, very true.
SV and impulse. It's not like SV or impulse test. It's something like non-intrusive test. And based on capacitance and frequency response, based on capacitance and inductance value. I would like to study on this, whether it can be applied to the series or fault or some other phenomenon that can cause safety to the installation. Let me try along with Aurora Ji. Every seminar I would like to pose a question to Aurora Ji, because he is the person acting as a pivot to organize all these people and get the correct input from the experts. In this today also, I would like to request him to take this as a point, and how we can interpret or use such gadgets to save lives of people and property, whether it can be a condition monitoring or a preventive maintenance. That's only one point.
Point well taken, and we will talk on that topic again.
Okay. Thank you, Ji. Thank you, and I wish you
Thank you.
to bring so many.
Now, I would like to invite Dr. Vikas Almari. He requested me to give him a chance to speak for this legend, K K Murty Sir. Kindly, sir, kindly unmute and.
Sir, I am not a legend. I am not a legend. I am an average. I have been an average testing engineer only.
Gulab, kindly unmute Vikas ji.
Yes, sir. I have unmuted him.
Sir, kindly unmute now.
Yeah, Mr. Murty, first of all, Happy New Year to you.
Same to you, sir.
Everyone here, very, very Happy New Year to everyone. Thanks, Dr. Arora Sahab, for allowing me to enter even at a late stage. I just requested you that Mr. Murty Sahab ka Ashirwad mujhe lena hai aaj. Yeah. So great, sir. Your know-how and your experience is unmatchable. Nobody can compare to this, and it is our luck that basically we have person like you in our lives who is giving such a good knowledge and such a good analysis that you do, and this is learning and inspiration for all of us. So thank you very much for great.
Thank you so
great.
much.
I joined in the last part, but everybody would love to do that. It's great thing, sir. Thank you very much. Thank you, Rajesh Arora. Thanks everyone, and keep blessing us.
Thank you.
May
Now,
God bless you.
kindly,
Not.
if you are available. Why, sir? Gulab, allow Why Saab to unmute.
सर इनका पीपी वाई सबका वॉइस का वो नहीं आ रहा है, मतलब ये कनेक्टेड है ओनली थ्रू वीडियो।
Sir, I think you are not connected with audio system.
यस सर, यस सर।
Okay, in the meantime, I would like to start question answer session. And sir, as usually I do, I would like to start with my question. Only one question I have to make. I have seen your presentation, 44 pages of your slides. You have mentioned the 4 cases of doing that test: open test, short circuit test, intermediate, inductive and intermediate capacitive test. What I feel, I am also a field engineer. We are using only 2 tests, open and close. We are not using inductive and
Yeah.
capacitive. Why we are not using it? Can you throw some light on that part?
See, it is more because you can get the this condition of the transformer by using those 2 tests, and the other tests need a lot of calculation also as far as the capacitance is concerned. For though people are doing that when the capacitance is different, capacitive test. After doing the capacitive test, there are certain calculations are to be done to find out the basic capacitance. That has to be done. In comparison with the actual capacitance, which generally these OEMs do not do. So that is one thing. And as far as the other test is concerned, this is something like TTR, what I have shown about the the later innovative idea, you can see. So in that, the inductive test is similar to that. That is TTR, something turn to turn ratio that has been done. So that has that is a sort of that I got it from Transformers magazine, you see. So that is internationally known, and that is that's a knowledge to me as well, because I had no idea about that. So I read that, so I thought why not project it in this
Thanks
webinar.
for that. Thanks for sharing. Now I think Vai Saab is connected with audio. Kindly unmute.
Hello. Hello, are you getting me?
Yes, sir. Yes, sir.
Yes, sir. Yes, we are getting you.
Hello.
Sir, we are getting you right now.
Yeah. Yes, friends. Good evening, Rajesh ji, Murty Saab, all the participants listening my voice. My happy New Year from my side, folded hands to all of you, and I wish and pray that you get all happiness and success in the coming year. That is a wonderful event I could ever say. I am sitting before the 2 gems of the country, 2 stalwarts of the country, and not that I am exaggerating anything. It is your hard work. You are the most affectionate persons, as you know it. But what I say is not that there is any exaggeration. I say you are always working so hard for all of us, for the professionals, for the nation. I don't have words to put it for both of you. Really, you are the gems. You are the.
Sir, I give full credit to you, because you have given me the
That is the message of New Year. A person, you see, elder to me, Murty Saab in age, is doing a wonder, as you very rightly said, Rajesh ji. I salute him always, that he is really a gem. And then the other person, Rajesh ji, I always love to appreciate him, because he is a person who is always doing sacrifice, even from his end for the nation. Recently, on the eve of New Year, now he has spent 80,000 from his pocket and purchased the equipment for measurement of the fault resistance impedance of the circuit. Carried out the first time this test in the country on fault impedance. And I could see the test. You see exactly even on the Google he displayed. And the wonderful thing he has shown, yes, is a stabilizers we are using at home. and
Yeah.
we are not taking into cognizance the resistance that is adding up. And as a result, there are flashovers. As a result, there are accidents. So all his life, I know the background of Rajesh. Since beginning, he's really a good guide for youngsters, for others, various professionals. How in a disciplined way he was saving 10% of his salary before he did his PhD. How he has spent even now recently 80,000 from his pocket so that we can learn something
Yeah,
about.
yeah.
He is always trying his best that the country,
So,
there are no accidents. There are no accidents. That's a unique mission he has started. Every now and then I see that he is somewhere is making the people have the oath about that there should not be any accident in the country. So
Thank you, sir. Thank you.
doing multivarious things always. So I think your presentation, Murty Sir, it is one of the best presentations I've ever seen and listened to you today. One of the best presentations. Flawlessly you covered it up on the subject. Flawlessly, I say. No, it was wonderful presentation. Very good graph shown, very good presentation. And I think all professionals will be gaining a lot from. I know you see the conventional tests are not helping at times, but the SFRA test you have shown in detail, what are the contingencies, when to do it, all the things will be captured have been captured by the professionals, and it will go a long way helping the electrical engineers in the country to take advantage of that.
Thank you,
So
sir.
all my
Thanks a lot.
best wishes for both of you. You are
Thank you, sir.
both wonderful people. Wonderful
Thank you.
persons. Thank you. God bless you. God bless
Thank you.
Right.
Now, I request everyone whosoever wants to ask any question are free to ask. They can raise their hand and we will unmute one by one. Sunil sir, please unmute.
Very good lecture and inspiring lecture given by Murty sir at this age. Really, we are very much motivated. I have got 2-3 questions here. First question is that whenever we are carrying out the test, we found that some deviations in the graphs at different levels, ABCD levels. So particularly when there is a deviation in the B and C portion, because deviation in the A portion that we can understand, it may be due because of the residual magnetism and all that. But deviation at B and C portion, it is there. So there is a cross correlation factor is there. So how much cross correlation factor can be considered for allowing the deviation? Okay, have you got any example?
No, I have no inputs about that. But yes, deviation, whenever the deviations are there ought to be some problem. See, so there is no, you cannot limit them. What is the deviation like? That's what I feel. Maybe you can throw better light on that. You are welcome.
Okay, sir. My second question is that at the same time, there is a graph of the phase shift also. But I have also come to this test, but we are not using this graph, phase shift graphs. Can it be used for investigation or detection of the fault purpose?
Which phase shift?
Now we are just repairing the dB gain graphs only.
Yeah. dB graph only. Mostly people use dB graph only. So as far as phase shift graph is there, I have no idea about that because Dr. Arora will be able to highlight that.
Sir, you are very rightly said. If you look at the IC and IEEE guides, they always talk about that dB magnitude as well as the phase measurement to be done. But we are using almost in all the utility one particular make kit is used to measure the 10 delta. And with that kit, they themselves always recommend to do the DB test. They never give training for that face measurement also, and they themselves don't have idea about that measurement in comparison. This is the only reason in India we are not doing it.
Okay, okay. Now my third, it is not a question, but it is an experience to share with you. For the incipient faults, where there is no any indication of the any protection, differential protection, REF protection, overcome upward
But
protection.
in incipient faults of DGA, you will have to see that.
Yes, yes, DGA is there.
Yeah.
Because alarm is there, but
Yeah.
SFRA or other tests, when the other tests are very normal.
No, no, SFRA will not help you.
Will not detect the problem.
No, it will not help you. SFRA will not help you because DGA can be this thing. The transformer has got many aspects. You see of thermal. See that yes, as I've said, if it comes to T3 level, that is more than 700 degrees, then definitely you will have to see this SFRA as well.
Especially when your DJ is showing the more rate of change in the acetylene value, that means it is in the T3 zone.
Yes, yes, acetylene. Yes, it comes in
to take a shutdown and go for the SFRA to a certain to know more about the health of the transformer you are using.
Okay, sir. Thank you very much. One thing I learned new from your SFRA this lecture, that is the how to take the turns ratio with the help of this ratio. Thank you very much.
Sir, you are in which organization, sir?
Sir, I am retired from MECTCL, Maharashtra Transmission Company.
Okay. I know.
He's also legend like you. He's going to be giving presentation in the next presentation.
Okay. Very good.
I'm going to call him.
I know Mr. You know that Rajurkar.
Rajurkar is there. Yes.
Yeah, I know.
Yes.
Any more question or should we close? Kindly raise your hand if you have any question. Otherwise, we would like to say goodbye because we are already running out of time. I think, sir, there is no question.
And I think running out of time is because of me.
No. Because of the best session we have ever we have ever arranged so far here.
Thank you so much.
And with that, I would like to say thank you to everyone and Happy New Year to everyone once again. More webinars come with more legends, with your wishes, with your blessings. Thank you, everyone. Thanks a lot.
I am not a legend, sir.
Thank you.
I am not a legend, sir. It is you made me legend. It appears. Don't tell me that I am a legend. No, I am not a legend. I am an average admin testing.
Thank you, everyone.
Thank you so much. Thank you so much.